Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. For tonight, we're excited to learn a little more about CAS and how you can use CAS to help teaching Algebra 1 and Algebra 2 content. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. We're lucky to be joined by our two panelists, Robin Gopinski and Scott Knapp. Robin's in her 13th year of teaching and is currently teaching Algebra 2 Trig Honors, Pre-Calculus, and AP Calculus BC at Highland Park High School in Highland Park, Illinois, a suburb north of Chicago. She has presented at numerous local and national conferences on how to transform your classroom using fun CAStic activities, two-way meaningful learning using the TI Navigator system, investigating rates of change via the CBR2, and bridging coding with calculus via the TI Innovator Rover. She served on the board of MeCAS, which hosted the USA CAS International Conference, with the last time being held in 2019 at HPHS. She pilots new software updates, has co-authored the one-day PD workshop on leveraging the TI Innovator Rover in the math classroom, and also became a TI regional instructor in 2018. She believes integration and technology in the classroom allows students to be actively engaged in their learning through mathematical exploration and discovery. So Robin, it's definitely great to have you with us tonight.
I'm excited to be here. Thanks, Mike.
And Scott is in his 22nd year of teaching high school math and currently teaches Algebra 1, Algebra 2, and AP Calculus AB at Glenbrook North High School, in Northbrook, Illinois, also a northern suburb of Chicago. Scott is an AP Calculus reader and has been a T-Cube regional instructor since 2011. Has led numerous workshops on a TI-Nspire graphing calculator, as well as started on authoring teams for TI-Nspire and TI-84 professional development. Scott enjoys presenting sessions at local, regional, and national conferences on how to use technology to support student success in learning mathematics. Scott, thanks for joining us tonight.
Thank you so much, and good evening to everyone.
And I think, Robin, will you start with our agenda for tonight?
Basically, we're going to go ahead. Our overall theme tonight is to really talk about how CAS can engage all learners, regardless of ability, level, and really across the spectrum, regardless of what math course you teach. Although tonight we're going to specifically be focusing on just the Algebra 1 and the Algebra 2 classroom. But there's a lot that you can still leverage with CAS in pre-calculus, calculus, geometry, and so forth. It's going to kind of be twofold. Tonight, we're going to first just talk about what is the CAS basics and what Scott and I consider three of the major power tools with CAS. And then we're going to switch gear and really show you how you can leverage and utilize CAS specifically in the Algebra 1 classroom or the Algebra 1 curriculum and the Algebra 2 curriculum. And then we're going to finish with the webinar drawing by you.
Thanks, Robin. And Scott, can you talk through our expected outcomes?
Yeah, we're definitely hoping tonight that you're going to be able to understand the advantages of having a CAS calculator, either in the hands of your students or as a teacher displaying the CAS on teacher software. We want you to leave tonight just knowing how to use some of the basic CAS tools and CAS functionality, and how to use that to help encourage your students to explore math a little bit. And then finally, we want you to leave with this kind of idea that I'm going to go and take this and use this in my specific classroom, my Algebra 1 and Algebra 2. So you're going to see some specific ideas on how to do that to help encourage your students to, be engaged in the math and let CAS be a tool to help them learn the math.
Scott, thanks so much. We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Robin or Scott using the Q&A window on the right side of your screen, and we'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. So Scott, I believe I give you control. Feel free to share your screen.
Yeah, here we go. So we've just got a short little introduction before we get officially started here of our own. And so it's just loading this. And Robin, go ahead and start us off here.
Okay, so basically, often we're asked what's the difference between the Nspire CX and the Nspire CX CAS calculators. And CAS is not new. CAS has been around for, I think, about a good 20 years. And about 12 years ago, it became the CX, so it was the color calculator. And basically, the difference, the driving force between the CAS and the non-CAS is you have an opportunity to see both exact answers and being able to manipulate with variables or symbolic manipulation. And so we're going to be talking about and showing that, demoing it at the very beginning with CAS basics.
Okay. And let's see. Here we go. Next slide here. So why do we CAS? And I think there's a lot of reasons why, and I'm not going to read through each of these individually, but we hope that you can, leave here again tonight thinking about why is this and why is this something I could intentionally use in my classroom to help students understand math. We've experienced, number 3 here on the list, more excitement and enjoyment in the discovery of math. And we've seen a lot of that with our students. I like the second to last bullet as well, the discovery of patterns and relationships. And I've worked really hard probably in the last year. I'm teaching Algebra 1 again for the first time in I don't know how long. And it's the first time I've actually used the CAS to help them learn math and discover those patterns. And there's a lot of great things that you can do with CAS. And so there's a lot of reasons why we do. Now, we're going to talk a little bit about our different perspectives on how we use CAS in our own classroom. So Robin, how do you use CAS up at Highland Park High School, just up the road from me?
Okay, so basically 12 years ago, I came back. I piloted with my AP Calculus BC kids. It's a huge hit. The more math you know, the more powerful the device is. And so the following year, I wanted to advocate that our Algebra 1 students use it. That way we got the technology in the hands of our freshmen and they would have it for 4 years. We made sure that we provide the opportunity for any student, regardless of what math class they were in, to purchase them. And in that second year, 800 students went and purchased them. So by the third year, our district said we're all in, and we decided to go one-to-one with the CAS only calculator. So in a district of about 3,300 students, all of our students have their own handheld CAS device. And we have approximately about 25% on the free and reduced book plan. And so we have a rental program where we got calculators through grant money that enables all of our students to have access to the technology. So all the teachers have the teacher software and our students all have the handheld devices as well.
That's great. Now, all of my students at Glenbrook North, just down the street, we're actually we're in the same conference athletically. We're a little bit of rivals, I guess, but we have calculators. But long ago, when we decided to use the Nspire, we went the non-CAS route. So my students didn't have the CAS. Now, recently, we've opened the door to students making choices about whether or not they're going to have the CAS versus non-CAS. And to be honest, the reason we went non-CAS was due to standardized testing. I think it's the ACT, that our students were predominantly taking. We wanted them to use their own calculators for that. But as things have changed a little bit, it's opened the door for CAS. And why I bring that up is that I think sometimes we think, well, if our students don't have a CAS, I guess I'm not going to be able to use this stuff. And that's completely not true. We all have access to the teacher software. And before my students even started having CAS calculators, that's what I was using, was teacher software to demonstrate things with CAS. So just that alone is powerful enough and a reason to really embrace CAS. Now, as the last couple of years my students have started coming in with CAS, I've been able to do more with my students in my classroom. Right now in my Algebra 1 class, about half of my students have a CAS calculator versus a non-CAS CX Nspire. And so I've been able to group them up into small groups where they have a calculator and a device to explore some of the patterns and things you're going to see. So I think the important thing is to realize that no matter what your environment is as far as technology goes, there is a place in your classroom for CAS, and there is a way for you to deliver instruction using CAS, even if your students don't have it on a handheld. So we just kind of wanted to share that a little bit before we get really involved here.
And I think that's kind of what Scott and I are hoping to achieve with this webinar this evening is to really shift the preconceived notions about CAS, that it's simply an answer finder. And it's not. That's going to be really our primary drive for this evening. We have to realize with the pandemic and students learning remote learning that they've had access to CAS through many different forums, whether it's, you know, searching on Google,
Photomath.
or Photomath. And so we're going to just kind of show you how powerful CAS can be. And that, like I said, kids have access to CAS-like things. CAS is not new. It's been out and about for 20 years. But making that leap of faith, and I can seriously say, when we said we were all in, it was a leap of faith. And it was like going from a flip phone to a smartphone. And I can't imagine going back in terms of how things have shifted in terms of the learning environment for my students because of CAS. And so we hope we convey that with you this evening.
Yeah, and I saw a quick question come in from Mark from Longmont, Colorado. Yes, the CAS does come as part of this premium teacher software. You have access to both the CAS and non-CAS sides of the software. So yes, definitely. Okay. Now, real quick, we just want to do a little bit of a quick poll with you just to get a feel. It's not going to change what we do tonight, but just for our perspective of things, how do you currently CAS? And any of these answers are appropriate. From 0 to 3. 0 being I'm totally new. I just came here to learn. I know what it is. I don't really know how to use it yet. I use it from time to time, but I know there's a lot to learn. Or I use it often, and I'm still looking for new ideas. And that's kind of where I'm at. I'm still looking for new ideas. So we're just curious. And we have a lot of zeros coming in, Robin, which is good because we've got some people that we can show some good stuff to tonight, and hopefully next time they'll be at 1 or 2, right?
Yep.
Yeah, okay, good. Thank you for sharing that. We were just curious, but we were just, yeah, so we didn't get all the chats from everyone. Mike, how are things looking? Are you getting some personal chats there?
No, it's mostly like zeros. I'd
Yeah.
say zeros is the heavy favorite, maybe some 1s and 2s.
Okay, all right.
And
So
also, if you get the teacher software CAS, you can turn CAS off now. That's actually
right.
one of the advantage now to the CX CAS II calculator, is that you can toggle between both.
Yeah, and so, you know, a lot of times we were worried about our students just having the CX, and then there was press to test. There's kind of a CAS press to test, so to speak, that's really easy to use as well. So just something to keep in mind. And before we get officially started with the presentation tonight, you know, we were trying to change the narrative a little bit on CAS, because I think over time, CAS has become this, oh, well, we don't want our students to have that power to use in my math classroom. But it's not just a device to compute answers. If you use it appropriately and intentionally, you can actually leverage it to teach how those answers are determined and how they are computed. And we hope that that's what you leave here tonight with, is that this isn't a bunch of button pushing to get some nice, pretty answers, but how can we use this to intentionally teach math? Okay, so with that, let's go ahead and get started with Robin kind of sharing some of the basics of using CAS and a little bit of comparison with the non-CAS calculator.
Great, thank you, Scott.
Robin, I'm turning it over to you.
Excellent, thank you. All right, so just to get us started with the basics here. If you were using a scientific calculator, or you're using the non-CAS, as we like to affectionately call it, if your students were making any kind of calculations, and this is something we're familiar with, this is hopefully why you came to see the difference with CAS. If they were trying to simplify a radical on the calculator, they could not do it. If they were trying to figure out a volume or an area formula, they would get all these approximate different types of answers, okay? But if they had the calculator that was a CAS, and I'm just going to go ahead and add a page here. Let me see if I can slide this up. Just going to go ahead and hit menu. All right, and we are now to go ahead and do that on the CAS calculator. If I go ahead and hit the square root of 18, they're now going to go ahead and see 3 rad 2. They're going to see the exact form. If we're going ahead and doing pi times 3 squared times 7, you know, they're going to get it in terms of pi. And that's a big deal when we're in geometry, when we toggle between asking kids to give us an exact answer versus an approximate answer. And then the students are always asking how many decimal places. And there's, you know, appropriate context for each situation. So 1,000 e to a certain power, you know, we can get that answer as well. You know, I love the whole notion here. If we hit control fraction, when students are getting the situation where they are evaluating quadratic equation to find solutions, and you know they're seeing the reduced form. And grant you, this is great conversations. There's so many great conversations you can have in terms of how the answers are displayed, and talking about how students are used to seeing, you know, the opposite of b plus or minus the square root, and why it is that the calculator reversed that. And then last but not least, I mean, this is very, very powerful, being able to do trig functions in radians and seeing the value in exact form, okay? So this is just, so at the very beginning, the difference between exact versus numeric answers and what CAS can allow you to do. And you can actually do both, because I could go up and if I wanted to see a decimal form of this value, I could just hit Control Enter. And so I can see, and I can get an approximate answer or I can get an exact answer. Okay, so that's one of the first CAS basics, and that's some of the power. And we'll be leveraging into the symbolic notation and manipulation in a minute. But first, I'm going to go ahead and hand it over to Scott, who's going to go ahead and we're going to talk about the symbolic manipulation right now, and utilizing variables to demonstrate how we can combine like terms. Okay, so
Okay.
So
So do you want?
if you could go ahead, yep, if you can go ahead and let's just take something basic, right?
So you share it over to me, Robin. Okay.
I
There we go.
just
Okay.
did. You got it?
All right. And so do
Perfect.
you want me on the CAS or non-CAS?
On the non-CAS.
Okay. So I'm on a non-CAS calculator right now.
Okay, and so you can see that the setup of the handheld on the left-hand side is different. You'll see if you're using the teacher software, and keep in mind, you can get access to this teacher software right away by contacting TI, and that's 1-800-TI-CARES, C-A-R-E-S, and you can start demonstrating what we're doing right now with you, with your students in your classroom. Okay, you can be projecting it on an overhead screen. So that's really, really important. If you're like, oh, this is great seeing all this, but I can't get the handhelds in my students' hands, you know, you can start demoing this as well. Okay, can you go ahead and type in a squared plus 4a squared?
Sure.
And let's see what the non-CAS shows us. Okay, and this is what's beautiful about the Nspire in general. It's very specific in telling you an error message and why something doesn't work. Okay, so it's saying that no value is assigned to the variable. So it'll evaluate an expression if you define that variable, but it cannot do symbolic manipulation like the CAS, CAS can, or the CX CAS, I'm sorry. You want to share it back to me so I can just show some of the power
Sure.
of the CAS doing the symbolic manipulation?
Let's see. I think I accidentally unshared. So Robin, I think you can go ahead and share.
I can't. Oh, I got it. All good to go. All right, so we are back at it. Okay. All right, so I'm just gonna go ahead, I'm gonna just add a page. I like to do that. I always like my students to save their work. And so we always work within a document. And that's another aspect of this webinar that we want you to be very clear about. We don't have the time to show you how to use the Nspire. There's so many facets and workspaces and graphing features, and we could toggle between showing symbolic manipulation, numerically, graphically, algebraically. We're focusing specifically on the power of CAS. Why CAS? Why it's worth investing your time and your students learning in your classroom to utilize CAS. Okay, so if I go ahead and type the exact same thing that I had asked Scott to type, you can see the difference, Right now, I can go ahead and do symbolic manipulation with variables. And it doesn't have to be just, A, B, and C. It could be something like, say I want to teach students how to combine like terms, doing like 3C plus 2D plus 4C, and teach them how to combine like terms. What is wrong with me doing, say, hey, what is 3 cats plus 4 dogs plus 2 cats? And this is the power of the computer algebraic system, and that it'll see that kids will say, oh yeah, of course, 3 cats plus 2 cats is 5 cats. And so if you transitioned it into something like 3C plus 4D plus 2C, then they can grasp like, oh yeah, that's why it's 5C plus 4D. You can do some unique things like that. If you're going ahead and we're talking about the principal square root value, and we have something like x squared, you can talk about and define why it's showing that absolute value symbol. And you can go even one step further. If you're linking all those letters together or the symbols together, the calculator is going to view that as one variable, okay? So I could go ahead and do something like this, dog squared, and it'll give me the absolute value of dog, okay? So that is just some of the basics with that symbolic manipulation. Why don't we go ahead and just take a quick moment? Is there anything that anybody who's here, any of our participants would like to see us type in? Anything you want us to experiment and try just for a quick minute here and find out? And Mike or Scott, if you can help me with the chat so I can just keep my shared screen open, that'd be great. Oh,
Somebody
division
said
or exponents.
exponents. Yeah, that's one of the things we're going to show later, but let's go ahead and just show that one particular skill now.
Okay. So I can go ahead and we can do it with variables right now. So we can do a to the 5th, and we will really be getting into this later on. Divided by a cubed, and you'll get a squared. And this is great. Like when we talk about how much the CAS has enriched those conversations and discussions in my classrooms, it's by the littlest things. If you hover over this explanation symbol, and it'll tell you like the domain of the result might be larger than the domain of the input. And you can talk with your students like, what does that mean? So there's all kinds of symbolic notations that'll come up on your screen that you're going to want to address, and things that the kids will naturally stumble upon, and it'll provide, a great conversation for you to have with them. All right, I'm going to go ahead and transition now into something I absolutely love to do when I taught algebra for 10 years. And so last year was I stopped teaching it this year, but I can say that I can share a lot of the really cool things that I love to do with them. And this was one of my absolute favorite things to do. And it was to have my students, when we started solving equations, was to have my students solve the equations on their calculator. And I will go ahead after I show this to you, I'll show you how I structured one of the assignments. And I'm very fortunate, like I said, that my students each have their own handheld, so they could go home and do the homework on their handheld. And the next day when they came to class, they would send me their homework via the Navigator system. Okay, so for example, if we have something like 2x minus 19 equals 13, I'll have my students go ahead and they'll type the equation on a blank calculator page on the calculator. Okay, on the screen, I'm sorry. Okay, let's do. Yes, it can do all of that as well. All right, so if we go up and grab this, so what I have my students do is I want them to recognize that what we were doing to x, an equation is essentially 2 equal expressions. And so what we did to x was we multiplied it by 2, and then we subtracted 19 to get the result of 13. And so when we want to solve an equation, we've got to go backwards. We've got to undo those operations. So this is always neat to go up here. And what I like about the blank space is I tell my students it's like, it's a blank canvas, it's like playing in the sandbox. And so they start manipulating, saying, okay, I want to add 19 to both sides. They get that value, they can go up and grab it. And then I say, okay, now what would you do? And what's nice about the power of the CAS is that they see the 2 times x. So if I want to undo it, I need to do the inverse operation. And so what's the inverse? What does that dot mean? It's the multiplication symbol. So undo it, I need to divide both sides by 2. Okay? And last but not least, how many times do we teach how to solve an equation? We tell students to check their answers, but how many times do they actually do? So after my students finish doing a problem like this, they need to go up and grab the equation and bring it down, and they need to substitute in their value into the equation. And if they get true, that means it's a true statement. They did it correctly. And what's neat that comes about from doing all this is you can start giving students all kinds of equations that normally we'd be hesitant to do, you know, on paper, especially if we were doing something without a calculator, especially the CAS. So all of a sudden I can give my students just some of the craziest expressions, and really it's all about, do they understand how to solve an equation, right? So anything can fly here in terms of what they're doing, okay? And so what's nice about this is often, you know, teachers will say, oh, first combine the variables on one side and the numbers on the other side, and that's not true. Some students might want to combine the variables on one side first, and it doesn't matter which side. And this calculator allows them to be in the driver's seat with that learning. I primarily also like just the conversations I would have when the students would have something like this. Okay, let's just do 4. And how often have I heard from students who say to me, oh, if I have a fractional coefficient, I need to multiply both sides by the reciprocal. And that's not necessarily true, because some students will look at this and will say, well, wait, it's 2 times x. So, okay, I have to just divide both sides by 2 first because I got to undo it. And then maybe they'll go up and grab this and say, oh, instead of dividing by 3, now I need to multiply by 3. And so I find that this really has generated a much deeper understanding of how to solve an equation. And how powerful is this when you go ahead and you get to something like this, and they want to go ahead and solve it, and whoops, sorry. Just go back. And they get an identity. And they're like, wait a second, I can't go up and grab it. I can't solve it. Or what happens if this is like a 3? Okay, and they get a false statement. So something of that nature. Okay, and so really quickly, I'm just going to go ahead and just show you the structure of this and how I would go ahead and structure an assignment like this really quickly. So you have an idea of how my students would be doing this activity. Okay, so their homework would be structured like this. They would create a title page, and notice after the title page, which is page 1.1, they would do one problem on each page. And so I would just go ahead and scroll between the different problems, and I wasn't afraid to give them any kind of problems. So these problems were all done 100% on the calculator. And then of course I had them do problems by hand, showing me all their steps on paper, but utilizing the calculator to go ahead and check their answers, okay? And last but not least, really quickly, I just want to show one more thing. Right. When the students are comfortable with just, I have them, this is a slower process, having them, what they do to one side of the equation, they got to do the other side. When they get more skilled and they understand that whole idea of balancing, then they can go ahead and just say, okay, I just need to subtract 1, and the CAS will go ahead and do that to both sides. So if I want to just divide by 2, it'll take that previous answer and do that. And that's particularly really neat to see when we start doing something like 1 is less than 3. And how often do students struggle to see why, whenever we divide or multiply by a negative number, we need to reverse the inequality sign? So this is a great opportunity for me to go ahead and demonstrate this using the power of CAS. Okay, and so students will be like, okay, yeah, that's true. But now if we have something like this, if I multiply both sides by -2, notice how we get a false statement. And so we have a conversation where we say, well, of course, -2 is not less than -6. So what do we have to do to make that a true statement? And my students will say, well, we have to reverse that inequality sign. So this is what I'm talking about, utilizing the power of the CAS calculator to really have deep conversations. And you could start addressing the what ifs. And I find that we have far more what ifs because students will say, well, what happens if we did blah, 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 or blah, blah, blah. And I'm like, well, why don't you go ahead and find out? Let's see. So that is just some of the CAS basics. I know, Scott, why don't you go ahead? I'm going to stop sharing. So you can go ahead and get into talking about the big three major CAS tools, okay?
So the CAS, the computer algebra system, has a lot of different tools that are in the different menus, but there are three that I found I use more than the others. And so I call them the big three. That's just kind of my name for them. And so I want to show you, so I'm not on the CAS, or that's the non-CAS screen. Let me come over to my CAS. If you're on a calculator screen and you press menu and you slide down to algebra, that's where you're going to find a lot of the tools that you can use with your computer algebra system on your handheld or software. And these first three are what I call the big three. They're the first ones there. And I probably honestly use them kind of in order of, the tool I use the most is the solve, and then the factor and the expand. But I'm actually going to go in reverse. And just to make you aware of what these different tools can do, and some of the questions that people were asking or wanting us to try are hidden in these tools. So I'm going to grab the expand tool, and it can pretty much expand just about anything, symbolically. So if I tell it, oh, I don't have times in there. So that X in front, I need a times attached to that so that it knows I'm trying to multiply X by 2X plus 3. And you can see that it expanded that expression. And that's not anything fancy, but I'm going to come up here and just recopy this down so I don't have to grab the tool. But if I want to expand two binomials, it can do that. I think we saw somebody say just a little bit ago, what if I want to expand a binomial, binomial expansion like X plus Y to the fourth? And very quickly, it can compute that out. So a lot of different things you can do. I also like that it can expand things that are in forms that maybe are not typical to us. So if we look at something like this, which my students, if this were set equal to Y, would know is vertex form, it will expand that into the standard or general form, depending on what you call it. So expand has a lot of potential and a lot of possibilities. And to be honest, sometimes I use it just myself when I'm trying to find that next example. So I just did some polynomial functions work. And let's say I wanted to have some zeros at, plus and minus 3i. I wanted a double root at 2, and then I wanted a single root at -5. I can find the function that I want to give the students that would have those various zeros and roots to them. Okay, so the expand tool is very powerful, and that's one of the big three. The second tool in the algebra list of the big three that I want to show you is the factor tool. And I want to show you something first that can actually be used on a non-CAS, because there's a lot of things you can do to leverage here the factor tool. It can actually factor numbers. And when it factors numbers, what it's doing is it's just listing the prime factors of that number. So right now it's finding the prime factors of 6. And if I want to come in here and maybe change this to, I'm trying to think of another number that I want. What about the prime factors of 30, or 2 times 3 times 5? Or even, something like 30,030. I don't need the comma in there. And it can find you the prime factors of that number. So that's pretty powerful. But with CAS, remember, it's not just numeric. It's that we can do things symbolically as well. So I often use that factor tool to factor variable expressions. So let me go grab that tool again. Yeah, and I'm having some trouble with getting the tool. So I'm just going to, you can also type, which is what I'm doing here on my keyboard. Okay, and so just like expand can expand two expressions, factor can factor an expression into, oh, that one doesn't have factors. So that was a prime expression. But what if we had a non-prime expression, x squared minus 2x, and then how about minus 24? We can see the two factors that makes up. And that's pretty nice. And in a little bit, I think Robin's got something that she's going to show you how you can use the factor tool to kind of look for some patterns. It can factor not just trinomials, but it can factor binomials. I just did an activity with my students a couple weeks ago with this, where it ended up factoring as a difference of two squares. And it can factor even your higher degree polynomials as well into the factors that make that up. So that's kind of the second of the big three tools. And probably the one tool I use the most is the solve tool. And it's pretty powerful. It can solve just about anything that you send its way. So again, that's in the algebra menu. And the first tool there is solve. And so I'm going to have this now solve a couple of different types of equations. So we'll start off kind of boring. Now, one thing I want you to notice is that the notation for solve, I haven't had to do this yet, and you'll see why we need to do this here in just a little bit. But I gave it a linear equation in the parentheses, and you've got to type comma x because it wants to know what are you solving for. And that will make more sense here in a little bit, but it can solve linear equations. I've used this to actually solve some nonlinear equations. We did some work with absolute value equations. So if I type in something like the absolute value of x is 3, comma x, it will give me the solutions to that equation. It can solve quadratic equations like this. And it can also solve over complex numbers. And if you just type a C, or there's actually a complex solve tool, I won't go and find it right now, but if you type a C before and we ask it to solve something like x squared plus 32 equals 0, it will solve over the complex numbers, non-real and imaginary parts to those numbers as well. So that's pretty powerful. What I really like about it is not just that it solves numerically for me, but that it can solve literal equations. So first, what I'm going to type in here is familiar to most of us, the area of a triangle formula. So if I write this formula and I ask it, please solve for h, this is why that's so important to put comma h, because you see here there's 3 different variables. If I had solved this for b, it would have told me a different answer. And I'm guessing here, I don't usually do this, but if I had solved it for a, it's just going to repeat out what I had before. So it can solve literal equations. So think about, and this is one thing, I'm probably newish to the CAS. I'm newer than Robin in the last, I don't know, 3, 4, 5 years, maybe 4 years. You start to play around and think about, I wonder if it can do that. It hits me all the time. And so tonight I was just thinking, what would be a good example to show people the powerful, the CAS's power in solving something that's literal. So I thought, well, what about the slope formula? And a lot of times we want students to realize where the point slope form comes from. So I'm going to have it solve for y2, and we see the point slope form. Now, one thing to notice here is notice how it wrote the point slope form. It's a little bit different than what we're used to seeing. And that's something you've got to realize with CAS, is that it's programmed to solve in certain ways, based on how you label and number things. I think earlier tonight, I actually tried this as y1 minus y2 and x1 minus x2, and I got something, nope, well, I got to solve it for y1, sorry. If I solve it for y1, it actually looks a little bit more like the point slope form we're accustomed to. So you've got to realize that sometimes you're going to get answers that maybe they're equivalent, and that's kind of important, right? We want our students to recognize when things are equivalent. It's not always going to look the same, and that comes up later on in higher levels of math, especially in AP Calculus. A lot of times we're looking for equivalence and recognizing that. Probably the most powerful equation I've had this solve, or at least that wowed me the most, is this one, because what we have here is a quadratic equation with unknown coefficients, a, b, and c, and it's set equal to 0, and I'm going to have it solve for x, and look at how fast CAS can solve here, and what we've got in front of us is the quadratic formula. Again, not quite the variation that we teach students the quadratic formula, but one that's equivalent, okay? So that's the solve tool for you. And and one more thing, it can also solve inequalities. I just played around with that tonight. I've never used the solve tool for that, but you can solve inequalities. So once you learn these tools, and these are the big 3, the sky's kind of the limit. You'll start to find little ways and think of things like, oh, I wonder if it will expand that. And sometimes it might not be able to, but often it can. And it's really kind of cool and a lot of great math there. Okay, so what we're going to do now is we've shown you kind of the basics of CAS. That's what Robin introduced. And I've showed you the big three. But the most important thing, like we said at the top, is how can we use this to teach math? It's great that we can get all these things and we as math teachers are like, that's so awesome. But how can we use these various basic functionalities and tools to intentionally teach some math? And so I'm going to toss it over to Robin, and she's going to show you a few activities that we've put together where you can actually use CAS to look for patterns in math and then build off of those patterns. So Robin, I just shared over to you. It'll be there in a second.
So what we kind of demonstrate in some regard is that preconceived notion about CAS being that answer finder. So how do we leverage it? Well, we leverage it by really shifting the way that math is traditionally taught. Okay, so I know this is kind of a generic statement, but traditionally what happens in a math classroom is kids come in and the teacher teaches the math. You know, it could be some kind of hands-on, maybe it's a worksheet, manipulatives, whatever. Kids will do practice problems, and then hopefully there's an exploration and some kind of enrichment. The CAS calculator allows you to completely switch it. Kids are now doing the explorations. They are in the driver's seat. They are now in control of their learning. And I will tell you, the conversation, the enthusiasm in the classroom is tenfold better than anything I ever had. And so what we're going to show you is some of the activities you set up in advance. So as a teacher, you set it up in advance. But once you go ahead and do it in the classroom with your students, you are doing less in the classroom and they are actively engaged. And that's always something that I'm always striving for, is my students to be actively engaged, focused, and excited about making the discoveries through number, patterns, and explorations. So I'm going to do 3 simple ones with Algebra 1. I'm going to toss it over to Scott to show you some examples with Algebra 2. Okay, so the first one somebody put in the chat a while ago was about exponents. And so we do an activity with exponents. And so I actually even start off, before I do the activity, kids don't understand what an exponent is. And so it can be something as simple as just putting in, what is A times A times A? It's really simple. And what does the exponent mean? Well, the exponent is a condensed way of writing A times A times A. The 3 tells you how many times you're multiplying the base together. And so, you know, you can go ahead and they have something like that, and maybe they're going to toss in a couple of B's like this, and then maybe we're going to multiply another A in there. And they start getting the idea of what the exponent means. So here we're multiplying 4 A's together times 2 B's. And what we do, and this is, I know Scott does something comparable as well, but we create an activity, and this is something that we are happy to share out with you guys at the end. Just go ahead and show you what it looks like. Oh, wait, hold on a second. This is not the one I want to show you. Okay, so generally they'll have some kind of structure like this. You walk in and you're going to have the students, and this is true differentiation, right? We have all these education buzzwords that we're often hearing and tossing around. This truly is differentiation. Kids are working at their own pace if you're able to get them handheld devices, or you could be demoing this once again on the screen. And you literally have the kids type in exactly what they see here. What's A cubed times A to the second? We tell them don't do anything by hand. And then you see if they can come up with the rule. And you might simply just have, depending on the level of your learners, you know, you might say, could you come up with a rule for what you see occurring? Or you can have it more directive with a fill in the blank like we did here. And we can go through the different operations in an activity, and then you bring the students back together and you have them drive the math. Okay, and they're coming up with the rules or the algorithms, and they're excited to be able to share up their observations and things that they played with. Okay, so I'm just going to show you a couple of these things really quickly, and I want to make sure that Scott has enough time to share with you some of the algebra too. So, I mean, let's talk about doing the division. So once students start seeing something like this, let me just go ahead and put it in there. And they figure out a squared times a to the fourth. So I'm multiplying 2a's together times another 4a's, it's a to the sixth, and they're starting to notice the pattern that when you're multiplying with the same base, you add the exponents. And so then you say, okay, can we do something generic with this? Does it matter a to the m power? Doesn't matter what it is, times, let's say, a to the mth. What should happen? And they're like, well, you should be adding m plus n, and they're going to see that. And they're going to see that with all kinds of relationships. And like I said, we can go ahead and we can do this with division as well. And they can be seeing that pattern with the quotient property. Let's go ahead and just demo a couple of these. I particularly love doing this with my algebra students with negative exponents, right? I mean, how many times did they think the answer is negative? Or I give them something like this. So let's make it a to the negative fifth, this one over. And then they're like, oh, you just put that power on the in the denominator. Say, well, what happens if it's like this? And this is what I mean, that what if. And we can toggle back and forth and like, whoa, now it's in the numerator. And then once again, we'll hover over that, that caution sign and we'll have a conversation about what that means. Okay. All right, another thing I want to show you really quickly is just the factor, and always throwing the students kind of a curveball. You know, they'll get really confident, they'll get really excited that they see a pattern really quickly, and then you always want to just, I call it throw them a curveball, just kind of challenge, expand their thinking, truly get at that critical thinking. And so Scott went ahead and showed you the factor tool. And so say you're just going ahead and you're teaching how to factor the difference between two perfect squares. And so you can give them all kinds of different powers and you're asking them, okay, are you seeing the patterns? What's occurring here? And often kids will say, oh yeah, I get that. I see what's happening, Ms. Kopinski. Maybe I'll just grab this one. You know, I can put a 16 in front. Okay, is the pattern still what you think it is? Maybe they'll put a b squared in front here. And they're like, yeah, you just square it the first one, you square it the second one. Well, okay, what about if I give you this one? Now what's happening? It's not 2n plus 6 times 2n minus 6. You know, what happens if I give them this one here and I go ahead and I make it plus? Is it still going to work? Oh, no, it truly has to be a difference between two perfect squares. And like Scott said, you can go ahead and put a c in front and it can factor over the complex numbers, which is something to do with algebra 2. Okay. Last but not least, and I know I'm talking fast because there's so much for us to possibly try to show you, and we're trying to do the biggest highlights here, is really rethinking how I've taught students to simplify radicals. Okay. So the square root of, let's say we do the square root of 49, okay? And they see it's 7. And then we say, okay, let's go ahead and factor 49. And they see 7 squared and say, okay, well now let's go ahead and let's square root it in factored form. Okay, and now I start having them look for patterns with these numbers. So what happens if I say square root 50? Okay, they get the value there. And now let's go ahead and factor 50. Right? And now let's just go ahead and square root in factor form. And what are we observing? What are we noting? And you can go ahead, you know, and really start changing this up for students, you know, by putting in larger numbers and talking about what is happening here. Right? Look at that one where you got multiple factors squared. And now if we go ahead and square root the factored form, what are we observing? Okay, so those are just a couple of the really quick tools, and I am going to go ahead now and send this over to you. Okay. I lost how to send it over to you.
Did you press share up at the top real quick? Oh, I am the presenter. I got it.
Good.
Okay.
All right.
So
show algebra 2, Scott.
Yeah, let's do it. Okay, so we just have a little bit more time. So just like Robin showed you kind of an algebra 1 activity that was not designed, this one's very similar, but now it's algebra 2, where we're having students type things into their CAS calculators and we're having them look for some patterns. While Robin was talking, I knew we'd be running out of time, so I went ahead and kind of just put together a screen of these so that you can kind of take a look at what students are looking at. And there's several examples, in each set that they're typing in. We kind of break it down so they're really investigating one property at a time. What happens if you sum two logarithms? And you can do that with numbers. You can also do that with variables, and then it reinforces the property of exponents activities that Robin just was talking about. What happens if you subtract two logarithms? And then what happens if you have a logarithm to a power? And I like to show all kinds of different variations, numeric, combinations of numbers and variables, and really helping the students to observe the patterns and then build the math from that. I've always kind of wanted to teach that way, and sometimes that's easier than others, but I feel as though CAS really takes a lot of that, it just enforces and encourages so much of that looking for patterns. We call ourselves pattern explorers all the time, and so students probably get sick of me saying that, but we're always looking for patterns. So that's kind of an algebra 2 version of the exploring patterns. I also just use CAS once in a while to demonstrate some things that I think are important. And so I want to show just a couple of things that I found are really neat that involve our big tools for CAS. My students just completed a unit on rational expressions, which is always one of the more dry things to teach and work through with students, but one of the more important things, knowing about what they're going to do with those in pre-calculus and calculus down the road. So important that they can work with rational expressions. And one of those things is how to find the lowest common denominator. That's something we use when we add rational expressions, subtract, and also we often use it when we're solving equations that have rational expressions. And so one thing I thought was, well, what if we take a look at the factors of each of the denominators, and then we have CAS calculate the lowest common denominator and see if students can recognize some patterns. And so that's what I did, is I had some students, and this is a class where my students don't actually have the Nspires, or the CASs. So I actually gave them some screenshots, just so I thought, in a couple of years, my students will have the CAS and then they can actually type some of these things. And it was pretty remarkable how they were able to look at a screenshot of the factors. So this is using that factor tool. And then, we haven't shown you all of the tools that are available, but in the algebra menu and fraction tools, there's a tool called Get Denominator. And if we type the rational expressions that we're finding the common denominator for, which remember we're 1 over x squared minus 36 plus 1 over x squared minus 8x plus 12, it will actually find the common denominator for that pair of rational expressions. And what we hope is, again, students looking for patterns, noticing that, first of all, those factors in the common denominator are the same. They're coming from the factors of each individual denominator. And of course, one example is never enough, right? So we've got to show them another example. And so I went ahead here, again, just to save a little bit of time. So my second example is this. And I had CAS go ahead and factor each of those two denominators. And that's what we have here. And here's a case where we have this repeated factor. So how does that impact the common denominator? And so again, if I go back to menu, algebra, and fraction tools, and then get denominator, I can type in my original expressions. And I always use control divides to get that fraction template up. And we can again see what the common denominator is, the lowest common denominator, and make some comparisons between how it gets formed and how we do need both of those factors of x plus 1. Okay, so that's one place where I found success leveraging the CAS tools. And I'm going to show one more here to kind of wrap up. And this last one it's probably one of the more powerful ways I've shown how CAS can really help my students understand something a little bit better that maybe I wasn't best at explaining, but using CAS really brought it to life. And so it's with transformations. And I want you to think about how you teach this, because it might just kind of change what you're thinking and how you might explain this. But it's kind of counterintuitive to me, and I think to students, when we think about transformations vertically versus horizontally. Because vertically here, when we have +5 outside, that's up. And we know up to be a positive direction. But when we have +5 inside here, and it's with X, that's left 5. So that's a horizontal movement, but in a negative direction. So why are those switched? And the same thing works with down, vertically down 3, and -3 is right. Those are kind of counterintuitive. Same thing with dilations. A 3 on the outside means we vertically dilate by 3, but a 3 on the inside means we horizontally dilate by 1/3. Why is that? Well, I think here's a really outstanding place to leverage CAS and show students why. And I always use the square root function, because if I didn't have CAS and I went through this without CAS, which eventually I want my students to do and think about, it's a function that they can actually do this without a calculator. So the first thing I want to do is I'm going to use that solve tool and have it solve my parent function for X. We always look at functions from Y's perspective. I use the phrase, functions are a very Y-centric world. It's always Y equals, Y equals, Y equals. But if we want to understand things from the horizontal variables perspective, we need to look at it from the horizontal variables perspective. So if we solve that parent for X, we get that X equals Y squared. Now we also get this little message, and this is important that you want to talk about that because it's restricted Y to be greater than or equal to 0 like it was from the original parent function. So it does give us that message. But now let's take a look here. If we solve, and I'm going to take that first example where, +5 outside meant up 5, the positive direction 5, but +5 inside isn't going to be right 5. Take a look at comparing here what we've got. Our parent, in terms of X from X's perspective, was Y squared. And look at what's happened to our parent when we have Y equals square root of X plus 5. Our parent actually has lost 5 because we've actually solved that equation and looked at things from X's perspective. And I think that's very powerful. And I've had many more students, I don't want them to memorize all of these things that, oh, we can trust things involving Y, but we can't trust things involving X. Why is that? Well, the key here is looking at things from X's perspective, and CAS makes that extremely fast and efficient to do. And so it's really cool. And so here we think, well, it should triple the X's. Actually, from X's perspective, it's taking what the values were and dividing them by 3. So a place that we can use CAS, I think, effectively and intentionally to reinforce what they're learning and knowing, and just giving them that extra little piece. And last thing I'll show here before I throw it over to Mike for our drawing, somebody had asked about binomial expansion. And this is kind of the next level with CAS. This is on a notes page. And many people know how to work with sliders, but you can actually create some things. These are called math boxes where you attach something to a slider. So right now it's raising X plus 1 to the n power, okay? And just look, if you look at the first row here, right now it's showing X plus Y squared. I went and I used the expand tool here in this next line, and it's now expanding that and showing the binomial expansion. And if you look at those two rows, you can see and think about all the patterns that we can have. And I actually have my students use this because I don't want them to expand past X plus Y squared. It's just tedious. I want them to start looking at the patterns as they increase the powers of the expansions. But one thing I found in the CAS toolbox, and if you play around enough, you're going to find these things and you're going to be like, why did anyone ever want this tool? Well, for me, this is pretty powerful because when we do binomial expansions, we talk about the binomial theorem. And you can actually extract the coefficients from an expansion. There's a tool called polynomial coefficients, polycoeffish. And if you take a look here, what is showing up here now in those brackets? What are those numbers, or where have you seen those numbers before? Can anyone do a quick chat? I can't see my chat. Is anyone noticing where those numbers are coming up? Pascal's triangle, exactly. Yeah, those are the coefficients in Pascal's triangle. So there's so much here. And again, how did I find this out? I learned a little bit and I played around. Let CAS be your little playground. You know, get that teacher software open and start thinking about things, how you can intentionally use the CAS in your classroom. You'd be surprised. It's almost something you can use. Find a day that you can't use it. You know, I think more than when can you?
And I hope we just show you something that you might be able to take away in terms of how the power of the CAS and how you really can leverage it and really shift how students are learning mathematically in your classroom.
Yeah. All right, guys. So we need to wrap things up tonight. We promised to give away a webinar drawing, and tonight's lucky winner is Jacqueline Perry. So, Jacqueline, congratulations. You have won a free registration to the virtual T-Cubed International Conference coming up this July. We'll be in touch over email to give you a little more information about that, but Jacqueline, congratulations. To receive your certificate of attendance, go ahead and click the link in the chat window. Also list this link for the documents that were used tonight. And what we're actually going to do is we're going to update the documents here probably later tonight, and then we'll be sending out a follow-up email in a couple days, and that will actually have, I believe, all the slides that you probably are going to be wanting from Robin and Scott. So feel free to download the documents as they are currently, but definitely whenever you get the follow-up email in a couple days, re-download those documents. They'll probably have some more goodies in there for you. And if you're watching this on demand, go and copy that link into your favorite browser to receive your certificate. So huge thanks to Robin and Scott for everything you put together for tonight. Thanks so much.
Thank you for
Mike.
coming tonight.
Yeah, thanks everyone for being here.
Sharing an hour of your evening this evening with us.
And we hope to see everyone back online next week. Have a great night and stay safe.